This year keeps surprising us. What's happening with the weather on our planet right now makes even experienced meteorologists scratch their heads. Fall 2025 has turned into a real marathon of extreme events, and it looks like this is only the beginning. While you're watching this video, events are unfolding over Europe and the United States. Just a couple of decades ago, these events would have made for a documentary film. But now, this is our reality. This material contains confirmed information about climate anomalies from the past week, what new terrible hurricanes have done, and what forecast awaits us in November. Let's start with Europe. On October 20th, 2025, at 5:30 in the evening, residents of the Paris suburbs heard a strange roar. At first, many thought it was an aircraft flying low. But within seconds, it became clear this was something completely different. A tornado formed just 12 miles from the center of the French capital. Within minutes, the storm flipped cars, ripped roofs off houses, and uprooted century-old trees. But the most terrifying part happened at one construction site. 3 massive cranes collapsed all at once. The collapse injured several people. The storm tore down power lines. About 1,500 homes lost electricity. The path of this monster stretched for several miles. The width of the funnel reached 330 feet. Here's what's really frightening. Such tornadoes are extremely rare for France, especially for the Paris region. The last time something similar happened here was in 2003. And back then, the tornado was significantly weaker. The most powerful tornado in all of French history occurred in 2008 in the town of Origny-Saint-Benoît. That storm reached category EF4, one of the highest ratings on the destructive force scale. Meteorologists from the French Weather Service were shocked. They recorded that the tornado formed from a supercell thunderstorm. This happens when a powerful rotating structure develops in a cloud. Usually, this occurs in the American prairies on the famous Tornado Alley, but not in peaceful Europe. The preliminary assessment showed that the Paris tornado belonged to category EF2 on the international scale. Wind speeds ranged from 112 to 137 miles per hour. But the tornado in Paris turned out to be just a harbinger of even more massive events. Just a few days after this, a so-called weather bomb hit Western Europe. Yes, meteorologists actually use this term, and it fully reflects the essence of what's happening. A weather bomb occurs when pressure in the center of a cyclone drops more than 24 hectopascals in 24 hours. It sounds complex and confusing, but in reality, this means the hurricane rapidly gains strength, literally exploding above your head. The wind accelerates to hurricane speeds. Torrential rains begin, and ocean waves reach heights of several meters. The French named this new storm Benjamin. And it didn't just arrive, it burst in. First, the blow hit the Atlantic coast of France. Coastal cities turned into disaster zones. Photos from Normandy showed apocalyptic scenes, as if a giant roller had passed through the towns. Then, Benjamin moved further. Its center reached the English Channel, the strait between France and Great Britain. From there, the storm continued its path northeast, affecting Spain, Belgium, and the Netherlands. Most importantly, this was not a random storm. Meteorologists warned that such weather bombs are becoming increasingly frequent. Germany found itself in a real trap. The country faced something strange, something impossible to fully prepare for. The German Meteorological Service issued a red-level warning, the highest degree of danger. This doesn't happen often. A storm circulation established itself over the country. But this wasn't just windy weather. We're talking about truly dangerous conditions. On the North Sea coast and in mountainous regions, gusts reached extreme values. The main threat lay in unpredictability. The wind intensified instantly during the passage of storm lines. Drivers on the autobahns, calmly driving at 75 miles per hour, suddenly felt an invisible force push their cars aside. Meteorologists warned about a special phenomenon that's rare even in the Atlantic. It's called a sting jet. This is a narrow airstream in the rear of the cyclone that multiplies wind force in limited areas. It appears suddenly, strikes precisely, and disappears just as quickly. In mountainous regions, the situation was even worse. On the peaks of the Alps, forecasters expected hurricane-force gusts. And you know what's most alarming? Forecasters say such weather bombs are no longer an exception. They're becoming the rule. Previously, similar storms happened once every few years. Now they occur several times per season. Besides the hurricane, a rare but very dangerous weather structure began forming in Central Europe. It's called the Rex blocking pattern. It sounds like the name of some robot from a movie, but in reality, it's a specific atmospheric configuration. A huge high-pressure system positions itself directly north of a low-pressure area. This system blocks the usual movement of air masses. Meteorologists noted that some regions of Europe recorded temperatures unprecedented for decades. People said there hadn't been such cold in early October since the 1980s or even the 70s. But while Europe battled Benjamin, an even more terrible story was unfolding on the other side of the Atlantic. In the Caribbean Sea, a tropical storm began forming. It would soon receive the name Melissa. And judging by all signs, this would be one of the most destructive hurricanes of the season. Melissa was forming in the central part of the Caribbean Sea, approximately 168 miles southeast of Kingston, the capital of Jamaica. Initially, wind speeds reached 70 miles per hour. This wasn't yet a hurricane by official classification, but very close. The main problem wasn't the current strength of the new hurricane. The problem was that the storm was practically not moving. Its speed of movement was only 2 to 3 miles per hour. When a hurricane moves quickly, it passes over a territory, unleashes rain and wind, and moves on. Yes, there's destruction, but it's localized. But when a hurricane almost stands still, it dumps torrential rains on the same cities for several days in a row. This is exactly what happened with Hurricane Harvey in 2017 in Texas. It stalled over the state and poured more than 3 feet of precipitation in some areas. Entire neighborhoods went underwater. The same thing happened in 2019 when Hurricane Dorian got stuck over the Bahamas. Now the same fate threatened Jamaica, Haiti, and the Dominican Republic. The National Hurricane Center in the United States issued a warning. Melissa could become the most powerful hurricane ever to hit Jamaica. This is a very serious statement. Nearly 3 million people live on the island, and all of them faced this threat. Climate scientists looked at satellite images with growing alarm. What they saw wasn't just frightening. It challenged all previous understanding of hurricane intensification speed. Melissa was over water with a temperature of about 86 degrees Fahrenheit. But it wasn't just about that. The most dangerous thing was that warm water extended deep below the surface. Usually, when a hurricane passes over the ocean, it mixes the water. Warm upper layers mix with cold lower ones. The temperature drops, and the hurricane loses energy. This is nature's braking mechanism. But in this case, warm water extended dozens of meters deep. No matter how much the hurricane mixed the water, it remained warm. In the 2025 season, out of 4 Atlantic hurricanes, 3 experienced extremely rapid intensification: Erin, Gabriel, and Umberto. And now Melissa joined them. 2 main development scenarios existed. In the first scenario, Melissa slowly shifts west towards southern Jamaica. There it enters a zone where the atmosphere and extremely warm water create perfect conditions. And then the storm transforms into a monster, a Category 4 or even Category 5 hurricane. After that, it turns northeast and threatens Cuba. Such a scenario would mean maximum hurricane strength and maximum destruction. But it would also mean less probability of a direct hit on the most densely populated areas. The second scenario was less powerful, but more dangerous for people. In this case, some weather factor could shift Melissa directly north toward Jamaica or Haiti. The hurricane wouldn't reach the strength of the first scenario, but it would deliver a direct blow to the islands. This would mean a concentrated catastrophe in densely populated areas. For the United States, direct impact was considered unlikely, but the East Coast expected strong surf and rip currents. Florida, however, remained in the risk zone. If Melissa turns north later than expected, it could reach the peninsula. In that case, Cuba and the Bahamas would also lie in its path. The National Oceanic and Atmospheric Administration predicted 13 to 18 named storms at the beginning of the season. 5 to 9 of them were supposed to become hurricanes. 2 to 5 were expected to be major hurricanes, with wind speeds exceeding 112 miles per hour. The forecast turned out to be accurate. The season was indeed active. But the most terrifying part was this. Forecasters could predict the hurricane, they could warn people, but they couldn't stop it. And then, wind speeds in the storm reached 75 miles per hour. Melissa still barely moved. This meant the islands would suffer from rain and wind not for hours, but for days, maybe even a week. In Haiti, where infrastructure was already weak after numerous earthquakes and previous hurricanes, the situation was already critical. Many people live in flimsy structures on mountain slopes. When landslides begin, escape will be almost impossible. In the Dominican Republic, officials evacuated or displaced more than 1,000 people. Schools closed. Streets in cities turned into canals. Some people tried to walk through flooded areas, risking being swept away by the current. Rescuers worked around the clock, pulling people from flooded homes. Now let's look at what forecasters predict for November. And I'll be honest, their forecasts make even the most optimistic people think. Climate models show Europe is entering a period of even greater instability. A classic autumn weather structure will form over the continent, a large upper trough in the west that will bring moisture and warmth. It sounds harmless, but in practice, this means prolonged periods of rainy weather with serious flood risk. Look at the sea surface temperature maps. Waters around Europe are now 1.5 to 3 degrees Celsius warmer than normal. The western central Mediterranean is especially hot. This is the main source of moisture for autumn storms. Warm water evaporates actively. Air becomes saturated with moisture to the limit. And all this moisture is ready to pour onto the continent as torrential rains. Models predict the formation of a powerful blocking high-pressure system over the North Atlantic. This will strengthen the pressure gradient over Europe and lead to a series of deep cyclones. Imagine a conveyor belt of frontal systems. One after another, they will roll across the continent from west to east. Scandinavia, Denmark, the North Sea, northern Germany. All these regions face a prolonged period of rain. But rain is only half the story. November promises to bring sharp temperature swings. The first half of the month could be abnormally warm. Most of continental Europe expects temperatures above normal. People will walk in light jackets, surprised by the warm weather. And then, a sharp reversal. Forecasters see a high probability of a blocking high-pressure system forming over Scandinavia or the Ural region of Russia in the second half of November. If this happens, it will open a path for Arctic air masses. Cold will pour into Eastern and Central Europe, possibly even early snow in the lowlands of Central Europe, Germany, Austria, the Czech Republic, and Poland. For Russia, the forecasts are particularly interesting. The European part of the country will feel warming in the first half of November. Temperatures will rise above normal. Forecasters call this Indian summer, but it's too early to celebrate. Then, a sharp collapse is expected. Cold air from the Arctic or Siberia will move west. Northwestern, central, and northern regions will face a sharp cold snap, wind intensification, and the beginning of the winter regime. In the United States, the picture is no less dramatic. For the southern states and the southeast, forecasters predict above normal temperatures and increased humidity. This will create conditions for severe thunderstorms and heavy precipitation. For Atlantic coastal regions, the threat of late tropical storms persists. Yes, hurricane season officially ends on November 30th, but nature doesn't read calendars. Storms can form in December too. History has proven this repeatedly. Northern states should prepare for winter's early arrival. Models show the possibility of cold western Canadian air masses invading. Climatologists explain that all these anomalies are part of one big puzzle. The planet is transitioning into a new climate regime right before our eyes. Arctic sea ice continues to shrink at record rates. Glaciers in Greenland are melting with acceleration. Permafrost in Siberia is thawing, releasing methane, a greenhouse gas that's 25 times more powerful than carbon dioxide in its impact on climate. Oceans absorb enormous amounts of heat. They work like a giant buffer, smoothing out temperature jumps. But their capacity is not infinite. Water temperature is rising, and warm water is fuel for storms. More heat means more energy for hurricanes. Fall 2025 has already become a visual textbook. Nobody expected a tornado in the Paris suburbs, the weather bomb, Hurricane Benjamin, that cut power to 100,000 homes. Hurricane Melissa, which could become the strongest in history. Early October snowfalls in the Balkans. This is the new climate reality we now live in. A busy November lies ahead. Then winter will come. And judging by all the signs, by the models, by what's happening with the planet's climate, this winter will be no less dramatic and unpredictable than this fall. That's all for now. Like this video and subscribe to the channel. This will really help our project develop.